All right, welcome friends. Mr. Burrell here. We're in the unit talking about solving exponential and logarithmic expressions. We've already talked a little bit about solving exponential expressions. So now we're going to talk about some properties of logarithms that will help us in later concepts and later lessons to solve logarithm expressions. So specifically, we're going to talk about expanding and condensing logarithm expressions. If you don't know what that means, that's okay. Probably none of you do. But by the end of this lesson, I will hope that you're able to use the product property of logarithms, the quotient property of logarithms, and the power property of logarithms, particularly with fraction, exponents, and radicals. So you probably don't know what that means yet, but we're going to get there. We're going to talk about what each of those things means. So first, I want you to take a minute and type each of these expressions in your calculator and see what you notice. Pause this video for right now. I want you to type these in your calculator and see what you noticed. Okay, hopefully you've had a chance to do that. But I'm going to type these into my calculator. So, for example, log of 3 times 4, that's 1.079. All good and dandy. That's great. I'm going to type log of 3 plus log of 4, and that's 1.079. Okay, let's do log of 9 divided by 7. That's 0.109. Let's do log of 9 minus log of 7 right here. I'm going to get 0.109. All right. Again, let's do log of 5 squared. Log of 5 squared, or log of 25, is 1.398. Now let's do 2 times the log of 5, and I get 1.398. Are you seeing something? I hope you're seeing something. How about log of 100 divided by 2? Well, that's equal to 1. And let's do log of the square root of 100. That is also 1. Look at what's happening here. Look at these different logarithm expressions. I want you to take notice and, I want you to take notice what's happening here. What do you see? How are these related? What are you recognizing? So, with that, I want to introduce these different properties associated very similarly with what you just did, the properties that are associated with logarithms. And I'm going to pop these up right here too, because you'll notice some of the properties we talk about in relation to logarithms are pretty similar to some of the properties that you've talked about in the past with exponents, like the product rule or the quotient rule or the power rule. Right here we have the product, quotient, and power rule of logarithms. I want you to pay close attention to how these are kind of connected, how they're different, how they're similar. So, for log base b, when b is some real number greater than 0 and not equal to 1, so most of the time we'll see like log base 6 or 7 or 12 or 10 or 3, whatever. Some whole number like that is what you'll see most of the time. If I have log of x times y right here, I can expand that logarithm as log of x plus log of y. So log of multiplication I can write as log of x plus log of y. That's the product rule. Here I have log of x divided by y is equal to log of x minus log of y. So when I have log of x divided by y, that's equal to log of x minus log of y. That is called the quotient rule. And here if I have log of x to the n power here, log of x to some power, then that power comes down in front and can be written, if I expand that out, as n times the log of x. That's called the power rule. So you'll probably see some similarities if you look over here with what we know about some of the different exponent rules. You'll probably see some similarities. But that happens with every single logarithm. You probably noticed here, again, log of 3 times 4, I can expand that out using the product property as log of 3 plus log of 4. Or if I have log of 9 divided by 7, I can expand that out and write it as log of 9 minus log of 7. If I have log of 5 squared, that exponent I can plop down here in front and write it as 2 times the log of 5. Right here, if I have log of 100 over 2, really I could write that as 1/2 times the log of 100. I could rewrite that as log of 100 to the 1/2 power. Or 100 to the 1/2 power is the same thing as writing the square root of 100. If I take 100 to the 1/2 power, that's the same thing as writing the square root of 100. So you notice these different rules, and we've kind of tested them out with some examples for ourselves. So hopefully we're convinced that these are true. When I go from here to here, I'm expanding a logarithm. I'm writing it out bigger. I'm writing it out as expanded as I can. When I go from here to here, I'm condensing a logarithm, or kind of condensing it all into one logarithmic expression. So let's practice some of these. We'll start with some relatively basic ones. So here I have log base 6 of 5 times 8. So this is what I'm taking the log of, 5 times 8. Well, the product rule says I can write that as log base 6 of 5 plus log base 6 of 8. And those two expressions are the same. And that's it. That's all you're doing right now. If I say expand this logarithm, I want you to expand it out as simplified as you can. So you have log of just one item or one number there. Okay, let's try another one. This one's a little bit more difficult. Here I have log of this jazz. 5 times 2 to the 5th, all to the 3rd power. And notice that there's a lot going on. There's several rules we're going to use. So I'm going to start kind of like I do with order of operations. I'm going to start from the outside and work my way in. So I'm going to start by dealing with this exponent right here. Well, when I have the log of something to a power, that power goes to the front. So this is really 3 times the log of 5 times 2 to the 5th. Like so. Now I have some multiplication in here. I have log of this times this. Well, when I have the log of two things that are being multiplied, I can write that as 3 log of 5 plus 3 log of 2 to the 5th. Notice how this 3 came along for the log. It's attached to this log now. It can't go away. So 3 times the log of 5 times 2 to the 5th is the same as 3 times the log of 5 plus 3 times the log of 2 to the 5th. Well, now I have another log with a power. This power can come down in front and multiply in front. So this is equivalent to 3 log of 5 plus 3 times 5 is 15 log of 2. So this whole mess right here is equivalent to or equal to 3 times the log of 5 plus 15 times the log of 2. That's pretty crazy. That's pretty awesome. Let's try a couple other examples. Log base 2 of 10 divided by 11 to the 3rd. So when I take the log of a division problem, I'm going to expand that out to log base 2 of 10 minus, because when I divide, it's expanding out into a subtraction problem, minus log base 2 of 11 to the 3rd. Okay, well now, this is as simplified as it can get right here, but here I have 11 to the 3rd. I can expand that out even more. So that exponent, whenever I have the log of something to an exponent, that exponent's going to come down in front. So I'm going to have log base 2 of 10 minus 3 log base 2 of 11. Okay. This problem right here is going to be very similar to this one. Notice I have log base 5 of a to the 5th minus log base 5 of b to the 4th. Then these exponents are going to be able to come out in front, and I'll be left with log base 5 times log base 5 of a minus 4 times log base 5 of b. That would be my final answer right there. And notice the structure here. Notice what's happening as we change. I think it's kind of cool to recognize how these change and how they relate. Let's do one more expanding problem. I have log base 2 of z to the 3rd times the square root of x. So when I multiply those, I can expand that to log base 2 of z to the 3rd plus log base 2 of the square root of x, or I can write the square root of x as x to the 1/2 power. Remember, I can write a radical as an exponent, so the square root of x is equal to x to the 1/2 power. Well, if I want to expand this even further, now these powers, these exponents, will go right in front of the logarithms. So I'm going to have 3 times the log base 2 of z plus 1/2 times the log base 2 of x. So that's how I expand that logarithm. Okay, we've had a lot of examples of expanding logarithms. Let's do some examples of condensing logarithms. So now I have several logarithms either being added or subtracted or whatever. I want you to condense them into a single logarithm. Let's start with this one right here. I'm going to rewrite this as 1/3 times log base 5 of x plus 1/3 log base 5 of y plus 1/3 log base 5 of z. So I just wrote, instead of log over 3, I wrote it as 1/3. Well, when I have a number out here in front of the logarithm, if I'm condensing, I can write that number as an exponent on what's inside the logarithm. So right here, I'm going to write each of these. I'm going to write log base 5 of x to the 1/3 plus log base 5 of y to the 1/3 plus log base 5 of z to the 1/3. Well, now I have 3 logarithms being added together. If I want to condense those all together, I'm going to use the product rule. So this is equivalent to log base 5 of x to the 1/3 times y to the 1/3 times z to the 1/3. All of that. So I could, if you left it like this on a quiz or on your homework, that would be fine, but I could simplify this a little bit more. If you remember some of the rules we know about exponents, I could rewrite x to the 1/3 times y to the 1/3 times z to the 1/3 as x, y, z all to the 1/3. Further, anything to the 1/3 power, if I'm talking about radicals, I could also write as the cube root of x, y, z. I mean, doesn't that look so much more friendly than this right here? Pretty cool that those can be written in these 2 different ways. So that's how you condense a logarithm down into a single logarithm. Let's look at this one. So first, I have these numbers out in front. So these numbers out in front can be written as an exponent on the numbers that are inside the logarithm. So log base 7 of 5 to the 5th minus log base 7 of 2 to the 6th. That's how I can write that. Now, since I'm subtracting these logarithms, I'm going to use the quotient rule and rewrite this as log base 7 of 5 to the 5th over 2 to the 6th. And for now, I don't need you to compute all those numbers and figure it out all the way. You can just leave it as simplified as that. And that's how I rewrite that logarithm in condensed form. Let's do a couple other examples. I'm going to erase these answers here real quick. If you need to go back and look at those again, you can. But these problems are going to be very similar to the ones to their right, or to their left. So I'm going to go through them relatively quickly. But I can write this the exact same way. Log base 4 of A, log base 4 of B, log base 4 of C, all divided by 2. So I can write that as log base 4 of A to the 1/2 plus log base 4 of B to the 1/2 plus log base 4 of C to the 1/2. And you notice, just like we did over here, when I add all these different logarithms together, I'm going to be using my product rule, and I'll be able to rewrite that as log base 4 of A, B, C to the 1/2, or log base 4 of the square root of A, B, C. Again, look how friendly that looks. Look how friendly that looks. I love it. On this problem right here, it's going to be very similar to this one over here. Instead of subtracting and using the quotient rule, I'm adding and using the product rule. So I can rewrite this as log base 3 of 6 to the 12th plus log base 3 of 11 to the 6th. And since I'm adding, I can convert that using, I can condense those using the product rule and write that as log base 3 of 6 to the 12th times 11 to the 6th. And that would be my final answer. take note here. You'll see this on all the questions on your homework. Note how all of these have the same base. Note how all of these have the same base. And note when we were talking about exponent rules, in order for those exponent rules to work, they had to have the same base. So in order to condense a logarithm expression or expand a logarithm expression, those bases have to be the same. Okay, that's all I've got for you in this video. Hopefully now you're able to use the product property of logarithms, the quotient property of logarithms, and the power property of logarithms, particularly when we're looking at fraction exponents like with those square roots and cube roots and things like that. Hopefully you're now more equipped to condense and expand logarithmic. I hope that was helpful, and I hope that you enjoyed it as much as I did.